So we talked a lot about patterns yesterday and how like noticing patterns is going to really help you in this unit, especially on Thursday when we start factoring stuff. Patterns are really going to help, okay? Not only do they help us make connections, okay? So they help us understand this stuff more, but they also actually sometimes are shortcuts and they make it a little bit less work, okay? So we're going to look for a pattern right now. We're going to look for there's going to be two main patterns today. One of them 100% you absolutely need. One of them you can kind of get away with most of the time, but still you really want to work hard to notice these patterns. It's going to make everything we do a lot better. I said yesterday, like grade 10 is a fundamental year. You learn all these really important skills that then grade 11 and grade 12 are based on all of this stuff, right? And factoring, what we're doing in a few days, is one of the biggest, most important things. If you're planning on going to grade 11 university next year, which I'm sure most of you are planning, at least at this point, you need to be really good at factoring. Like you need to be awesome at factoring. Is what we're going to start. We're going to review grade 9 factoring tomorrow, but start the real good stuff on Thursday. And we're going to do it for a few days. So there's lots of time to get there, but you've got to be awesome at it. Like in other words, if you don't get it, and by the end of this unit, you're like, wow, man, I still don't really understand factoring. You really need to think about whether grade 11 is a good idea because it'll be really hard if you can't factor. Anyway, the point is, it's all about patterns. Factoring is all about patterns. Okay, so we're going to look for these two patterns today, and if you get them, it's going to make that stuff down the road so much easier. This is what, don't write this down. I'm going to show you what people think is happening here. Okay, so we're going to run a little experiment. Is this true? This is what people think. They think this is 5x squared, which is 25x squared, plus 3 squared, which is 9. This is what people think. Why do they think that? Because if this was 2 times 5x plus 3, that's distributive property, and I do 2 times that and 2 times that. So then they think, well, it's that squared and that squared. But there's something that we're missing if we just assume that this is true. When you're learning this in grade 9, it's called the distributive property. Right? Is that what you call it? Do you remember calling it that? Distributive property. What's another property? So like black hair is a property, right? That's like a property that some people have and some people don't. Blonde hair, some people have, some people don't. Tall, some people are, some people aren't. Long hair is a property of some people and not a property of other people. Does that make sense? That's what properties are. Distributive is a property of multiplication. So when you multiply, you can distribute because it is a property of multiplication. It is not a property of addition. If this was 2 plus 5x plus 3, you don't go 2 plus this and 2 plus that. You don't do that because distributive is not a property of addition. These are like fundamental mathematics. That's like a deep mathematical concept. Anyway, so our question here is, our little experiment here is, do exponents have the property of distribution? If they do, then what we did over here is correct. If they don't, then what we did over there is incorrect. Likely. So how are we going to figure this out? How are we going to figure this out? Who can tell me what 5x plus 3 squared means? Or who can tell me what an exponent of 2 means? Who can tell me what an exponent of 2 really means? Jaden? This very nicely said, the same thing times itself. So do you agree it's like 5, if it was 5 squared, that's like 5 times 5, 5 times itself, right? Who agrees with that? You think that's true, right? Yes, that's right. There's not a trick. I'm not tricking you, right? Yeah. So how do we apply that in this case? Well, then isn't this 5x plus 3 times 5x plus 3? Yes? Does that make sense? Yeah, that's an exponent. We know that's true of exponents. Doesn't matter if it's a number a negative number, an expression, if it's squared, you multiply the whole thing by itself. If it was cubed, you'd multiply the whole thing by itself 3 times. Which would be messy. We wouldn't want to do that. But okay, does that make sense? You agree that this is okay? It is. I'm telling you it is, but do you agree it is? We're good? Okay, so let's expand this the long way that we know how to do it. 5x times 5x is 25x squared. That's my first term. What's my last term going to be? Well, yeah, it's going to be 3 times 3, which is 9. So look, so far, that's looking similar. But what am I missing? 5x times 3 and 3 times 5x. So 5x times 3 is plus 15x. And 3 times 5x is plus 15x. And what happens to those two? 25x squared plus 30x plus 9. Uh-oh. Is that the same as that? Please say no. Not the same. Why is it not the same? This is a trinomial. That's a binomial. They're not the same. That one's missing 30x. Which one do you think is correct? This is what a lot of people would have guessed. But I think when you follow these steps, you know that we didn't make any mistakes here. Everything we did here is absolutely 100% right. So this one's correct. Turns out that one's not. Turns out distribution is not a property of exponents. You can't do that. Even though we're making a big deal out of this right now, some of you are still going to want to do that. You're going to forget, and on a test, you're going to do it that way, the bad way, the evil way, and I'm going to go, don't do that. No, stop. Even sometimes, like, grade 11s and grade 12s do it, and I'm like, stop it. No, you're hurting me. Don't do this. Okay? That's not how you do it. And so you've got to remember that it should end in a trinomial. If you make that mistake, and on a learning goal or something, I go, look what you did here. Then what you can do is always write it out as 2 binomials. Because that'll make sure that you don't do this. If you write it out as 2 binomials, then it should remind you that, hey, this should be a trinomial. Okay? So, we haven't seen a well, okay, so that's that. Now let's think about, what else do you notice that's happening in here? Like, do you see anything that could be a pattern? Or do you see anything interesting? Two of those things are the same. 15x and 15x. Do you think that'll happen every single time that we do something like this? Not sure? What do you think? You think it might happen every single time? What do you think? Yeah. You think it will? Why? Because you're multiplying by itself. 5x plus 3 squared is always going to be times itself. That's what squared is. So you're always going to have 5x times 3 and then another 5x times 3. Aren't you? Your 2 middle terms will always be the same. Megan, you agree with that? What's my first term? My first term is the first term of the binomial squared, so 25x squared, because it's always going to be 5x times itself. My last term is always going to be, not 3 because it could be a different question, right? But you know what I mean? Like 3 times itself, or whatever that second part of the binomial is, times itself, right? So that's always going to be like 3 squared or whatever, right? 9. See the patterns happening here? Okay, so what does this mean? What if I do a plus b all squared? It's going to look like this. A plus b, a plus b. A times a squared. A times b, ab. What's b times a? That's also ab, right? B times a times b, that means the same thing, don't you agree? 2 times 3, 3 times 2, same thing. B times b, b squared. Look, same 2 things on the inside there. equals a squared plus 2ab plus b squared. This is one of the first times you're seeing something like this, so put your pencil down and just watch. You don't have to get this 100% today, but this is a really important thing to think about. So don't just give up on it, keep thinking. Okay, watch. A squared is like my first term squared. If my first term was 5x, it would be 5x squared. B squared is like my last term squared. So if my last term was 3, it's like 3 squared. Does that make sense? So what's this 2ab? It's a times b times 2. It's the first term times the second term times 2. 5x times 3, and I have 2 of them I'm adding together. So 2 times 5x times 3. 5 times 3 is 15 times 2 is 30. That's what we had up there, right? Look at 30. This is like a formula. There's a really important relationship happening here. Okay? So a squared plus 2ab plus b squared is like I can jump from a plus b all squared to that. We're going to see we're going to apply it in a minute, but this is like a general case. This is how we create formulas in mathematics or look for patterns, is we look at a general case and we realize that it's the first term squared, the last term squared, the first term times the last term times 2. When I have this situation, a plus b all squared. Yes?
Should it always be written like that, or should b squared be after the a squared?
Should what?
Should b squared?
No, we always write it like this. You'll see why when we do an example down below. What if I change it to a minus b all squared? Well, same thing. This is like a minus b times a minus b. A times a is a squared. A times negative b is negative ab. Negative b times a is negative ab. Negative b times negative b is plus b squared. And I get, in the end, those are like the inside steps, but I see the pattern, a squared minus 2ab plus b squared. So the only difference is this one's got a negative, this one's got a positive. Same sign as in the original example. We're going to look at an example of that in a moment, but we're going to do one other general example. What do you notice about this one, a plus b, a minus b? Yeah. Oh, interesting. So I don't know about that yet, but why do you say that? Okay, so everything else inside the brackets is the same. I got A, I got B, but the signs between them are different. This is a very special case. You have to know what's happening in this one. This is the one like you can't miss this one. You got to get it, but it's actually pretty easy. It's actually one of the easiest things that we do. Okay, so what would happen? A times A is A squared. A times negative B is negative AB. Positive B times A is plus AB. And B times negative B is negative B squared. And what happens when I simplify? A squared, these guys add to 0 minus B squared. What's different about this compared to almost everything else that we've done so far? Like everything yesterday when you multiplied 2 binomials, how is this different? Riley? Only 2 terms. And how many do we usually have? Very good. That's a pattern. So Riley already knows, hey, usually when we multiply 2 binomials, we get a trinomial. Usually. Not always, because look, you can get a binomial, and there's one case where you can get 4 terms. But okay? Does that make sense? So something different happened here. And it's a special case when you have the same thing, but plus and minus. That's why we call these special products. Any questions about that so far? Let's try an example. You can write it down, but just watch for a minute before you start trying it. x plus 5 all squared. Okay, so watch. This is how I apply that general form above. It's the first term squared and the last term squared. 5 squared is 25, right? X all squared is x squared, right? What's the middle term? X times 5 times 2. If I show, so here's the reason why you don't absolutely 100% need, especially yet, to get this one, is because I can just do this, x plus 5, which is x times x, x squared, x times 5, 5x, 5 times x, 5. Like, I can do this the long way. And then those give me 10x. I can do it the long way. But trust me when I tell you, once you get the shortcut, once you get this pattern, it's really going to help us in general, this whole unit. This is what this unit's about. Recognizing these patterns. Okay, I want you to try the next one on your own. Go. See if you can apply the pattern. Megan, tell me what you got. X squared minus 16x plus 64. You did that all in one step? Very nice. First term squared, x squared. Last term squared, 8 squared is 64, and it's plus 64. It's always plus in the last one. The middle one is negative because there was a negative here, and it's x times 8 times 2, so 16. So minus 16x. Okay, cool. Let's try another one. Rachel, what's 4x squared? 4x all squared. What's 4x all squared? 16x squared. Liam, what's 5 squared? Liam, over here on this side. 25. So that's my last term. You don't have to do it in this order, but sometimes that's the easy way to do it. How do I get the middle term? Who wants to explain to me how to do that? Liam, other Liam.
Times the first term by the second term.
Which gives you, so 20, and then? So minus 40x. And again, like there's a pattern. Notice how all of these are giving me x squared, then x, then constant. X squared, then x, then constant. X squared, then x, then constant. Like there's a pattern. You want to recognize that because this started with x and x, so I get x squared, x constant. Patterns, patterns, patterns. The more of these that you see and you get familiar with, the better you'll be. The easier this is going to be. The quicker you're going to learn all these things. Get really good at it. Alan, you had your hand up. Okay. What about the next one? Whoops. What's different? Madison, what's different? So it's like, it kind of looks the same, but instead of 2x plus 6, it's 6 plus 2x. It's out of order. A little bit different. In this case, it's not going to really make a big difference, but it is something to be aware of. If you just noticed that it was a bit different, good. Like you're seeing the patterns. That's really good. So I can do the same thing. What's 6 squared? Sebastian, you know what 6 squared is? 36. Ziggy, what's 2x all squared? 4x squared, yep, so plus 4x squared. And how do I get the middle term? Kristen, you know how to get the middle term? 6 times 2 times 2. 6 times 2 is 12 times 2 is 24, so plus 24x. This looks different because the original thing was out of order, so our answer is out of order. You don't have to do this, okay? Listen carefully because everybody wants to ask this question. Do we have to do that? No. The first line was correct, but it's not a normal way of writing it. We usually write it like that. It allows us to see patterns, get familiar with the answer and what it's supposed to look like. So it's not a bad idea to reorganize or just notice that it's out of order. Okay, what about E? What happens here? Alan, what do you notice?
There's going to be no middle.
Very nice. Why?
Because that's a plus and a minus.
Right. It's the same numbers, x and 3, but they're one's separated by a plus, one's separated by a minus. We sometimes call this like a sum difference product. It's the product between a sum and a difference of the same two things. So the first term is x squared. The last term is 3 squared, which is 9, and that's going to be negative 9, right? Because it's 3 times negative 3 is negative 9. And the middle terms would be positive 3x and negative 3x. They're gone. If you want to do that the long way, you can. You'll see that this is what you get. So what about the next one? Is it the same pattern, Zakira? What do you think? Two x plus 7, 2x minus 7. What do you think? It's a little bit different. Instead of x plus 3x minus 3, it's 2x plus 7, 2x minus 7. Do I have the same thing in the first spot? Do I have the same thing in the second spot? Are they separated by a positive and one's a negative? What do you think? Why?
I have an answer.
Okay, what is it?
4x
4x squared
squared minus 49.
minus 49. So it worked out. The middle term is gone. Yeah, that's true. It will. Yes, yes, yes. Don't be confused. 2x times negative 7, that's negative 14x. That's positive 14x. 0. Is that right? Any questions? Are you seeing the patterns? Okay, this one's a little bit different. We're going to do this together. When in doubt, you can always do this. Whoops, negative x squared plus 7. You can always write it out twice. This is negative x squared times negative x squared. What would that give me?
I just want to know, isn't that just like 1x2?
It's a negative 1 x squared. Yes, like negative 1 is the coefficient. Yes. Yep. Yes, exactly. And negative times a negative is a positive, so that's going to be x to the 4. So because I didn't start with an x, this one looks a little bit different. You won't see too many of these yet, but again, we will eventually kind of, so we want to get used to it. 7 squared is what? Jaden? So plus 49. What's my middle term? A times B times 2. 7 times negative x squared times 2. 7 times negative x squared times 2. Negative 14x squared. Very good. So a little bit different from all the other ones. Because what I started with was a bit different, so what I end with is a bit different. Okay, we're just going to do a few more examples. Try this one on your own. Tony, what'd you get?
81x squared minus 4.
How many people got that? Awesome. So you're getting this. Okay. Try that one.
I'm going to give you a little hint. You're going to just do this part.
I think you can do that part now.
Then you're going to go minus 2 bracket and do that part, right? Like the x plus 3 all squared in brackets like this.
Then multiply by negative 2. See if you can get the first step at least. And if you don't want to move on, you can wait.
So for this first part, you should have got 3x all squared, which is 9x squared. Negative 1 squared is positive 1. 3x times negative 1 times 2 minus 6x. How many people got that?
Good. Okay. And who can tell me what x plus 3 all squared is? Tara, can you tell me?
X squared plus, how many x? Plus 9? 6x plus 9. How'd you get that?
Okay. 3. Good. That's good. 3 times x times 2, right?
3 times x
Times 2. 6x.
Okay, and then we kind of know how to do this from yesterday, so let's, if you're done, that's awesome. You can watch and see if you got the right answer. Negative 2x squared minus 12x minus 18. It just starts getting kind of like, you just gotta make sure you watch the negatives and make sure you catch all the terms and everything. You don't miss anything. 9x squared minus 2x is 7x squared. Negative 6x minus 12 is negative 18x. And 1 minus 18 is negative 17.
Anybody get that? All on their own?
Fantastic.
Okay, try another one. I think there's this one and one more, that's it. Well, and then there's like 100 to do in the homework, but anyway. Try this one.
Okay, how many people got this to start? Compare your first line. 2x plus 4 all squared is 2x squared, which is 4x squared. 2x times 4 times 2. 2 times 4 is 8, times 2 is 16, so plus 16x. And 4 squared is 16. So far, so good?
Okay, slow down, watch. Everybody,
You can put your pencil down for a second and watch. I want to show you something. Minus, bracket. What's this all about? Same thing, 3x and 3x, 7 and 7, plus and minus.
so it follows that pattern.
Which is 9x squared minus 49. But Look what I have. Minus that. So this is a common mistake that people would make. In the next step, they would get 9x squared minus 49, but that's wrong because I have to distribute the negative, and that becomes plus. So I bet if you went ahead, there's probably a whole bunch of people in here who made that mistake. It's a really easy one to make. One of those ones you might make over and over again. Try to watch for it. Distributing a negative is often something that we miss, like even teachers miss it sometimes. Just hides for whatever reason, but be careful. Okay. And then, again, we're collecting like terms, so 4x squared minus 9x squared, negative 5x squared plus 16x, and 16 plus 49 is 65. Okay? One more. Any questions? One more. Okay, before you go too far, I want to talk about what's going on here. What do you notice? Does anybody want to like point something out? Like, does anybody notice anything? Jay, what do you think is going on up here?
There's two binomials.
Yep.
And
What about them? Do they fit any pattern?
no,
Why not?
because
It's 3x plus and 3x minus.
the numbers aren't the same.
So some people might think, very good. So some people might think that this is that sum difference product, but these are not the same number. So watch, it doesn't work out. If I'm going to expand this the old way, 3x times 3x is 9x squared. 3x times negative 9 is minus 27x. 6 times 3 is plus 18x. 6 times negative 9 is minus 54. They're not going to add to 0. It's one special case where that happens. Don't start pretending like that happens all kinds of other times. It's only in those other cases that we saw above. Okay, and what's x minus 1 all squared? Who knows what that is? Go ahead, Jen.
X squared minus 2x plus 9.
Okay, good. And then I'm going to simplify inside the brackets. So minus 9x minus 54 bracket plus x squared minus 2x plus 1. Distribute the 4 through 36x squared minus 36x minus, what's that, 216 plus x squared minus 2x plus 1. 36x squared plus x squared is 37x squared. Negative 36 minus 2 is minus 38x. And then negative 216 plus 1 is negative 215. Again, like, it's not the same kind of pattern here, but when you do enough of these, you just kind of know I've got an x squared here and an x squared here, an x here and an x here, a constant here and a constant here. Like, you just kind of know I got one of each. Sometimes you might not quite have one of each, or maybe you've got an extra, but you just get used to being that way. In grade 9, that would have been hard because you don't, like, x squareds go with x's, or I have to look at all the terms and figure it out. But once you've done enough of these, you start to see even like little patterns like that where you just kind of know what the answer is going to turn out to look like. Any questions?